Well, good afternoon. Hopefully you had a great day today. We are on sections 4.9, comparing and ordering rational numbers. So the question is, what is a rational number? Well, first of all, before we answer that, go ahead and hit pause and you can copy this information down. So go ahead and do that first. So going back to what a rational number is, it says rational numbers are any number that can be written as a fraction. And you say, well, what number can't be written as a fraction? Well, one of those possibilities, again, for a rational number, as you can see, 2 1/2, 1/3, 0.3 repeating, which is equivalent to 1/3 when we divide 1 divided by 3. That's the answer you get as a decimal. And then there's 7, and then there is 12%. And an irrational number would be an example like pi, where it's 3.14, but there's actually a whole list of numbers that is not a terminating decimal, meaning that it never does end. A 3.14, the value of pi, that is a rounded number. So that gives you an idea. Most, again, numbers that we all deal with are what we call rational numbers. There's very few that are irrational. And again, we will talk further about that as time goes along this year. Least common denominators, that is what we're finding today. And they also call that the LCD, which is actually the exact same thing as least common multiple, as what we learned the previous day. So when we look at 5/6 and 7/9 and we're trying to compare them or put them in an order from least to greatest or greatest to least, whatever the case might be, we have to find common denominators. We have to have this denominator being the same so that we can compare them with equivalencies. For example, when we have a slice of pizza and we have something like this, and one of them is shaded in to where it's 1/4. We have to make sure that we divide this pizza, if we're comparing, let's say, another possible pizza, which is 3/8, okay, and we have this divided into eighths, and we have 1, 2, 3 slices shaded in. We've got to be able to make this into 8 slices as well, and you can see that there are 2 out of a possible 8 slices for this particular piece that is shaded in. Now that we have equal amount of slices, the slices are the same size, we can now compare and say, well, this has 3 slices, this only has 2, this is the larger pizza. Okay? So that is, or the larger fraction, I should say. Just a quick way of discovering the difference between these two and why the importance of making common denominators, why that is. So when we look at these and we're trying to find common denominators, one way is listing the multiples and comparing. That is certainly one way, but we want you to get to the point to where you're doing it more of a mental fashion as well. And what I like to do is always start with the largest denominator, because that largest denominator in this case is a 9. It's never going to be smaller than that, because again, we're talking about multiples, not factors. So if we go by 9 and we say, well, does the other denominator go into 9 equally? In this case, it does not. So we do the next multiple of 9, which is 18. And does 6 go into 18? Yes, therefore we found it. So when you do this, you're going to compare, and you're going to say, well, this number is going to become an 18, so 9 times 2, so 7 times 2 is 14. And this is going to also, again, be equivalent to a number over 18, so we multiply by 3, so 5 times 3 gives me 15. Now I can compare and see that my 5/6 is 1/18 larger than 7/9. And again, these numbers are so close, 1/18 apart, it's virtually impossible unless someone's really worked with these types of numbers a lot to where they would know for sure that 5/6 happen to be larger. So very, very close these numbers are. That is why it is so important that you have found the common denominators, and I will require that on homework today as well, because we have to get into the habit of making certain of that. There's no guessing to this at all. So let's look at our next slide, and again we're comparing 5/6 to 7/8, or excuse me, 7/9, which is what we just did. And since the 5/8, excuse me, 5/6 is equal to 15/18, and my 7/9 was 14/18, therefore 5/6 is going to be larger. Okay, so make certain, and again you're just simply using the less than, greater than, or equal to sign. Okay, this line right here is just simply you filling that blank in. Okay, this is not a greater than or equal to sign. So let's look at our next problem. So go ahead and hit pause, and I'm going to let you find this, finding the least common denominator first. Well, when we do this, and I always like to set my problems up so that they're more vertical than horizontal, because then I can do all of my work off to the side. So again, I always start with my largest denominator, which is the 50. And so does 5 go into 50 equally? Yes, it does. Therefore, we're going to leave it 50, and this is going to stay a 7/50. This is going to equal a fraction over 50. So does 5 go into 50 how many times? Well, it's going to go into it 10 times. So 1 times 10 is 10. So you can see now that 10/50 is larger than 7/50. So therefore 1/5 is going to be greater than 7/50. Let's go ahead and see the next one. Go ahead and hit pause and try this. And again, these are negative numbers. Yes, you can have negative fractions. So I have my 9/16 and my 7/10, and we can start with this number and work from the 16, which 16, does 10 go into that equally? No. So then we try 32. Does that go into it? No. Then we can try the next one, which would be 48. And does 10 go into 48? No. And you're going to find that we keep going on and on and on. And you can go off to the side and say, all right, I'm trying to find a number that's going to end in a 0. So let's try 5. And we're going to do that, and that gives me 30. And then 5 times 1 is 1, plus 3 more is 80. So now I find that 10 does go into that 8 times. So let's go ahead and make this an 80. And yes, we're going to have to change both of them. So 10 times 8 would give me 80. So 7 times 8 is 56. And this one, what you said was, or we said, was times 5. So 9 times 5 is 45. And now we can see the difference. And 7/10, being 56/80, is larger than 45/80. Therefore, this is going to be, and again, we've got to look at our negative numbers. So if we're looking at a number line, okay, with this being 0, these are my negative numbers. The larger of these numbers, since this is negative, okay, my 45/80 is going to be over here, and my 56/80, since it's negative, is going to be out here. It's just like as though we're not even looking at my 80ths, which we really don't have to because they're common. And you can see that again, starting at 0, it's 1, 2, 3, 4, 5, and we get larger. The numbers themselves get larger as we go to the left. So when we're looking at this and saying, all right, which one is larger, it's actually going to end up being a little reverse psychology in a sense to this. and it's going to be the smaller number because it is a negative. And so, therefore, 9/16, a negative 9/16 is greater than a negative 7/10. Okay, this is where they make you do a lot of thinking and be very careful in doing these. So, and it almost caught me as well, as you might have noticed that oh wait, I forgot these are negative. So be careful with those. Now go ahead, we have mixed numbers. Obviously on a mixed number, if the whole number itself is one is greater than the other, then obviously we don't even have to look at the fraction because the whole numbers are going to tell the tale. However, they are the same, so now let's just look at the fraction itself. So 5/7 and 11/14. So go ahead and do that. So we look at the largest denominator, which is 14. And does 7 go into 14? It absolutely does. So we're going to leave this 11/14. And 7 times 2 gave me 14. So 5 times 2 is going to give me 10. Now we can look at our numerators, 10 and 11. So my 11/14 is going to be greater. So it is 5 and 5/7 is less than 5 and 11/14. Let's go ahead and look at our next one. And our next one is saying to put them in order from least to greatest. So what we need to decide, as you can see, there's fractions, decimals, percents, and another fraction. We just need to simply make a decision. Which of the three do I want it to become? Do I want them to become fractions? Do I want them to all become percents? Or a decimal. And in this case, I think the smartest thing to do, since they are all, most of them are fractions, I say you leave them a fraction. But again, it's personal preference. Some would rather make them all decimals. Some would rather make them all percents. So your choice. I am going to start with fractions and do it for this one. The next problem, actually, I'll do a little differently. So go ahead and hit pause and solve this. So I'll start with 7/10 and I'll leave that, and I'll leave my 16/25. If I'm going to write 6/10 as a fraction, you write it 6/10. And 72% is going to end up being 72 out of 100. So now we're going to, since we have them written all as fractions, we can make them all into common denominators. So again, start with my largest denominator, which is 100. And since this is going to is 100, we're going to leave it. This one, we're going to say 10 times 10 gives me 100. So 6 times 10 is 60. This one again is 100. So 25 times 4. So 16 times 4 is going to give me 64. And then 10 times 10 again. So 7 times 10 is 70. Now I can put them in order from least to greatest. And my, again, least is going to be this one. So that's my first. Second one will be this one. And my third will be the 7/10, and fourth will be 72/100. So what you want to do, since they gave us original numbers, I labeled them, but what represents my 6/10? Well, now first one is going to be the decimal 6/10. We've got to use the original one, so we can cross that off. And then, the 16/25 was a fraction. So we're done with these. And my next one, third with 7/10. And the last one, 72%. Okay. So let's look at our last one. So go ahead and hit pause and solve this. Well, you have a choice. We've got two fractions, we've got two decimals. And if I'm going to give you a different approach using the decimal values, so we already have our 3/10. And if you want to convert this to a decimal, again, you need to divide 3 divided by 5, which is going to give you 0.6, 6/10. And then we have 75 hundredths. And then 2/3. If you divide this, you're going to see that you end up getting 3 goes into 26 times, which is 18. Subtract, you get 2. Add a 0, bring it down, it's 20 again, so 6. And you're going to continue to see the repetition. So it's going to end up being 0.6666666. Again, it goes forever. Okay? So we can write that down. And we are trying to compare. So when you compare our decimal values, you're going to go to the first place value, which is going to be the 3, the 6, the 7, and this 6. And you can see 3 comes first. So over here, I'll do this in black, we get 3/10. Okay, so that one's done. Then we go to our 6, and you can see that the 6 and then this one has a 6. Well, when we do place value, again, you could put a 0 in here. So when we go to hundredths, you're going to see that this has a 6 compared to that 0. So this is like 60 cents, this is like 66 cents. And if we round it, it would be 67 cents. Obviously, this one is larger. Therefore, we're going to end up getting 6/10, which is equivalent to this. Okay, so we've got to write what they originally had, which was 3/5. Okay, and then we have the 66 repeating, which is equivalent to my 2/3, and the last one is my 75 hundredths for the last. So that is my order from least to greatest. Again, if you have any questions, please take note of that, and we'll be happy to answer those questions further tomorrow. So have a great evening, and we'll see you tomorrow.